They should send the design engineers and the executives out on the German Autobahns and see how long they stay alive in a car like that.
Well, oh yeah, you bring up some even more fancy tricks. So, what BMW is doing is that to get the tank down, they're using liquid hydrogen. Once again, you're driving around with negative 427 degrees in your trunk, and that's how they get any range whatsoever out of their hydrogen BMW. That's how they manage to keep trunk space. And yeah, there's some tricks you can do if you have access to ultra cold temperatures. Then you can sort of kludge your way to power, even with the low octane fuel. But no one seriously thinks that your neighbor is going to have negative 427 degree fuel hissing out of his car overnight. Okay, well here's something you might hear as a skeptic. When you lay it down on some believer or someone putting out talking points, when you really hit them on their talking points, oh yeah, well, this is the lateral. They once they know they've been beat, they immediately try and salvage it by coming up with their next talking point or their next whatever wrong thing they were believing in. But in the case of hydrogen, carbon capture and storage. Okay. Oh yeah, well, what if we produce hydrogen? Yeah, it's still coming from petroleum, but when we split it off, we can keep the carbons. It's logistical nightmare, as I've mentioned before, and is anyone actually going to do it? There are numerous reasons why fuel cell cars should just burn natural gas or methanol or any of the hydrogen carriers, in which case you're not going to do carbon capture because you have a million tailpipes running around, and you're not going to have sophisticated processing equipment that fits on a tailpipe with a guy who barely knows how to drive and goes to the shop once in, 8 years. And the gains you get by putting natural gas or methanol in your fuel cell are even beyond that. Because, once again, if you have a high temperature fuel cell, you're not only burning the hydrogens, but you're burning the carbon too, and that is useful energy. A car with a high temperature fuel cell can still manage to get some energy by burning the carbons. And yet another nail in the coffin of hydrogen only. That really, why wouldn't we just use natural gas or methanol or any other of the hydrogen carriers? Well, what about oxygen co-product? Yeah, so you split open a water molecule and you use the hydrogens. Now you have the oxygen, and you have 83% of your original water was oxygen. Well, what if we sell the oxygen, and that'll recoup part of the system, and in fact that's what's being done with ethanol right now. So with ethanol, you ferment your grains or whatever, sugarcane or whatever your plant matter is. You ferment that, you get the alcohol out, and you're left with the mash. I don't know, is anyone here a home brewer? But breweries and ethanol facilities, they produce this mash, which is the indigestible parts of the grain. They turn that around and they sell it to the farmers that they got the grain from to feed the cows and pigs and whatnot. Because in that particular case, they need protein. And take a corn kernel. Once you ferment corn and you get the ethanol out, you've pulled out the sugars out of your corn kernel, and you've left the proteins, and you also have proteins from the dead yeast. After fermentation is done, you got these dead yeast cell corpses or remnants, and it's called distillers dry grains and solubles. This co-product is a valuable resource. So they turn around and sell it to the farmers to feed to their animals. Okay, so oxygen. Let's do oxygen. Unfortunately, you're not going to find much money out of your oxygen because splitting apart electrolysis, your electrolysis equipment works at atmospheric pressure. There's not really much of an incentive to be doing this in any sort of fancy reactor. It's basically a chamber, electrode on one side, electrode on the other side. Simple equipment. But that means that when your unit produces oxygen, it's at atmospheric pressure, and it's kind of hard to work with. The two big users who might be buying all this oxygen, you've got the steel industry, who need to run their furnaces on air and not nitrogen, like I said, because they can't start burning nitrogen. And so they need high purity oxygen, and then various breathing needs, scuba, emphysema, hospital patients, persons who need respiratory assistance. You can't really sell them the oxygen that comes out of an electrolysis unit because you want to compress down that oxygen gas, same density as air pretty much. You want to condense that down into a bottle where you can ship it and move it and transport it and exchange it easily. And it takes energy to compress your electrolysis output into a nice, handy little bottle. You don't need that energy now because where commercial oxygen comes from now is people need liquid nitrogen, and then they sell oxygen as a nitrogen co-product. Various experiments, scientific experiments, and cryogenics labs, and lots of things. Cell phone towers. I believe, I don't know if it's nitrogen, but there is a cryogen in some cell phone towers. These industries need liquid nitrogen, and they get that by condensing air. Once you condense air, condense down to a liquid, pull out the liquid nitrogen, and you sell that. And you also have your liquid oxygen. You now have ultra cold, ultra dense liquid oxygen that you can transfer into a bottle and ship around in a nice little handy package. The liquid nitrogen industry does this. The hydrogen industry will not. So no, you're not going to be able to shave some pennies that way. Now here's a big one. What about fusion? The fusion future. Ooh, everyone's talking about, once mankind perfects, once we harness fusion, it'll be limitless power forever, power for everyone. And yeah, it'll be okay to waste energy splitting water. And you're actually losing water that way, losing energy that way, because hey, we got fusion, we got energy to spare. Yeah, okay, we have to throw away some, but we get this handy little fuel here. Unfortunately, no. Firstly, fusion is 25 years away, and it's been 25 years away for 50 years now. Like in the electronics industry, when you hear someone say, our next product, 3 to 5 years away. That's when you know use it. Sure it is. Sure it is.